everyone. On this video, we'll be going over rectangular coordinate systems. Alright, so kind of an introduction to rectangular coordinate systems. We're going to start with plotting ordered pairs. Okay, so when you're plotting an ordered pair, we're going to start on what they call the XY axis. Okay, so going from left to right, that's your x-axis. Okay, and going from top to bottom or up and down, that's your y-axis. You normally won't see the word axis, you'll see just x or just y. Okay, now the point where this xy axis intersects, right there, that's called your origin. Okay, so the point of intersection is the origin. Okay, now you may see this called a few different things, but they all mean the exact same thing. Okay, so it can be called the rectangular coordinate, which is what we're calling it now. Get that out of the way. You may see it referred to as the Cartesian coordinate system, or sometimes you may just hear someone call it the XY plane. Any of those names can be used to refer to this. Okay, so if you hear someone say, okay, draw a Cartesian coordinate, they just mean basically draw your XY axis. Okay, so now we're going to get into the actual definition of an ordered pair. Okay, so to plot your point on a graph, we're going to use the ordered pair x comma y. All right, so the x term or element is where you go left to right, or right to left. Listen, better say left or right. From the origin. Okay, so that means if you're starting right there at the origin, that first element will tell you to go either left so many spaces or right so many spaces. And the y element will let you know where to go up or down from the origin. All right. So let's do a quick example of plotting our points. All right. So if you're still writing, please feel free to press pause. We're going to do a quick example. Okay, so let's say, for example, we want to plot the ordered pairs. Let's say you have 1, 4, you have 2, 3. Let's say you have -1, 2, and you have 0, 0. Okay, so in order to plot our ordered pair, we need a graph. All right, so in most cases, you will use graphing paper. But for now, we'll just go ahead and draw our XY axis. Okay, so we have our X and we have our Y. All right, so starting at our origin, going for the X axis, that's going to give us 1, 2, 3, 4, 5, and we can keep on going if we make that longer, but 5 is enough. Okay, now starting at our origin, if we go to the left, those numbers become negative. -1, -2, -3, -4, and it'll keep on going forever and ever and ever, depending on how long we make our x-axis. Okay. Now our y-axis is the exact same thing as our x-axis, but it's going up and down. If you're going up, the numbers are positive. If you're going down, the numbers are negative. Same thing with the x-axis. If you're going to the right of the origin, positive. To the left is negative. All right, so we're going to start at our origin, and we're going to go 1, 2, 3, 4, and that should be good enough. And going down, that would be -1, -2, I'll go -3, and that's good enough there. All right, so now we're going to plot our 1, 4 point. Okay, so remember, for 1, 4, the x value tells us left to right. And the y value tells us up or down. Okay, so starting from our origin, we're going to go to the right 1 space. Okay, so we go to the right 1 space. And then we stop there. Now our y will tell us to go up 4 since it's positive. So we go to the right 1, up 4. So this is the point 1, 4. I think that was pretty painless. Let's try the point 2, 3. Okay, this one will tell us to go up 2 since it's positive. So if we, not up 2, to the right 2 since it's positive. So we go to the right 2 spaces. And this one will tell us to go up 3 spaces. So if we go to the right 2 and up 3, we'll be about right there for our point 2, 3. All right, so I want you to press pause, and I want you to try and do these next two. Alright, so assuming you've pressed pause and did those two, we have -1, 2. Again, starting at the origin, that's letting us know that we're going to go to the left 1 space because it's negative. But then from there, we're going to go up 2 spaces because it's positive. So we're going to go -1 to the left and 2 up. Okay, so that's our -1, 2 point right there. Okay, so now we're going to look at our 0, 0. Okay, so this lets us know, starting at our origin, since we have a 0 in our x spot, that we're going to move 0 spaces to the left or right. So that means we're going to stay right there. But a 0 in our right spot tells us the same thing. We're not going to move up or down at all. We're going to move 0 spaces up or down. So 0, 0 is the point of intersection. So that's your 0, 0. So I'm just drawing an arrow there since it's not enough room to put it right there. And 0, 0, as you may have guessed, is actually just your origin. So when they say starting at the origin, they're basically telling you to start at 0, 0. All right, so hopefully that made sense. So now we're going to look at ordered pairs as solutions. All right, so if you're still writing, feel free to press pause. We're going to move on. Okay. So the ordered pair is a solution to an equation in 2 variables if replacing the x and y will result in a true statement. If replacing the x and y will result in a true statement. All right, so you may run across some equations and they may say for this equation here is this particular ordered pair a solution. That just means plugging in those x and y values has to result in a true statement. Otherwise, it's not a solution. All right, so let's do a quick example. Well, a quick couple of examples. Okay. Let's just say for 3x plus 2y equals 6 is 1, 1 a solution. All right. So to find out the answer to that, it's pretty straightforward. So remember, for that particular ordered pair, remember the element on the left is your x value, and the element on the right is your y value. We plug our x value in for x and our y value in with y, and if that comes out to be a true statement, then we know that 1, 1 is a solution. Okay, so we started off with 3x plus 2y equals 6. So let me straighten that out a little there. There we go. Okay, so now we replace x with 1. So that means we have 3 times 1 plus, and we replace y with 1. 2 times 1 equals 6. Okay, so we know that 3 times 1 is 3, plus 2 times 1 is 2, equals 6. So basically that gives us 3 plus 2 is 5. So we have 5 equals 6, which is a false statement. Okay, so the fact that plugging in x and y gave us a false statement, we know that the ordered pair 1, 1 is not a solution. It's not a solution to 3x plus 2y equals 6. Okay, now I'm sure 1, 1 is a solution to a lot of other equations, just not this one. All right, so let's try another example. Move that up a little bit. Okay, so for example, let's say for 3x plus 7y equals 17, is the ordered pair 1, 2 a solution? Okay, so we have 3x plus 7y equals 17. All right, so just like before, well, better yet, I want you to press pause and try this one and find out if it's a solution. All right, so assuming you have pressed pause and worked this one out, to find out if 1, 2 is a solution, remember the value on your left, that's your x value, and the one on your right is your y value. All right, so we started off with 3x plus 7y equals 17. Okay, so we replace x with 1, so that gives us 3 times 1, plus replace y with 2, so 7 times 2 equals 17. Okay, so we know here 3 times 1 is 3, plus 7 times 2 is 14, equals 17. So 14 plus 3 is 17, so on the left we have 17, and on the right we have 17, which is true. So the fact that plugging in this ordered pair gave us a true statement, we can say that 1, 2 is a solution to 3x plus 7y equals 17. Okay, so hopefully that makes sense. All right, so if you're still writing, feel free to press pause, but we're going to move up to our next example. All right, let me bring down my paper here. Okay, so let's say, for example, we have to complete the ordered pair for 3x plus y equals 12 when, Okay, let's say for problem A, we know the first element is 0, but the second one is unknown. Let's say for problem B, we don't know the first element, but our second element is 6. And let's say for C, we know the first is a -1, and the second element is unknown. All right, so whenever they give you an equation, but only one element of your ordered pair, you plug in the one element that you know and solve for the one that you don't. Okay, so let's say for A, we have 0 and some unknown. Okay, so basically all this does is tell us that we know x equals 0. And all this is telling us is to solve for y. Because remember, our ordered pair is just x comma y. So we know our x, but we don't know our y. Let me kind of separate this a little bit. Okay. So if we have 3x plus y equals 12, and we know that x is equal to 0, that's 3 times 0 plus y equals 12. Now 3 times 0 is just 0, so we have 0 plus y equals 12. 0 plus y is just y, so that gives us y equals 12. Okay, so since we know that our y is equal to 12, this ordered pair becomes 0, 12. Or another way of saying this, when x equals 0, then y equals 12. Okay, hopefully that makes sense. Now we go to B, and we kind of separate that a little bit. Okay, so if we have some unknown x value and our second term is 6, okay, again, we know in this case y is equal to 6. Bring that down a little. Which means for this one, it's telling us to solve for x. That's our unknown. All right, so once again, we're starting off with 3x plus y equals 12. 3x plus y equals 12. And since we know that y is equal to 6, that's 3x plus 6 equals 12. You don't have to do the parentheses if you don't want to. So if we subtract 6 from both sides, we have 3x equals 12 minus 6, which is 6. So if we divide both sides by 3, anything divided by itself is just 1. That leaves us with x equals 2. All right, so that means this ordered pair, since x is equal to 2, will give us 2, 6. Which basically tells us when y is equal to 6, then x is equal to 2. Okay? So really all it is plugging in what you know to find what you don't know. Same here, plug in what you know to find what you don't know. All right, so I want you to actually solve for C. Okay, so if we have C is -1, some unknown. Okay, so go ahead and press pause and solve for C. All right, so just like the previous examples, we know x equals -1. So we solve for y. Okay, so if we have 3x plus y equals 12, we know x is -1, that's 3 times -1 plus y equals 12. Okay, so 3 times -1 is -3. So we have -3 plus y equals 12. So if we add 3 to both sides, these two cancel out. So we have y equals 12 plus 3, which is 15. So just move that up there since we're running out of space. So y equals 15. So that gives us the ordered pair of -1, 15. Oh, fill that in a little more. There we go. Okay, so hopefully ordered pairs are starting to make a little bit of sense. They're pretty straightforward. All right, so we're going to go ahead and go to our next example. All right, so let's say, for example, bring that down a little bit. We want to complete the table for the equation. Let's say y equals 3x. Excuse me. Okay, and let's say that our table looks like this. Okay, so let's say here you have -1, but nothing to the right. Let's say for this spot here, you're going to put 0. And for this spot here, you're going to put -9. All right. So I'm just going to redraw this table so I can fill in any missing ones. So we have our x, we have our y, and we're going to go ahead and fill in our -1, 0, and -9. Okay, so even though it looks a little different, this is the exact same as saying -1 and some unknown value. This one is the exact same as saying some unknown value 0. And this one is the exact same as saying some unknown value and -9. All right, so what we're going to do is now we're going to solve for those missing spots. And what we'll do is we'll call this A, call this one B, and call this one C. Okay, so this one's A, this one's B, and this one's C, just so we can clarify what we're working out. All right. So for A, remember that's just saying when x equals -1, solve for y. Okay, so remember we started off with a y equals 3x. Okay, and we know that x is -1. So that means y equals 3 times -1. So in other words, y equals -3. So in this one here, we know we're going to put in -3. Okay, so we're going to do the same thing here, and we're going to do the same thing here. All right, so let's go up to what we call B. So this one's basically telling you when y is equal to 0, solve for x. Okay, so again, we have y equals 3x, and we know that y is equal to 0. So we have 0 equals 3x, or 3x equals 0. It doesn't matter, I just feel better when my variable's on the left. So we make it 3x equals 0, but if you want to put it as 0 equals 3x, you're more than welcome to. Okay, so we divide both sides by 3. We have x equals 0 divided by any value other than 0 is going to equal 0. So whenever the 0 is on top, it's going to equal 0. So x equals 0. Okay, so that means this one just becomes 0, 0. Okay, and what I want you to do is go ahead and solve C. All right, so I'm assuming you've pressed pause, you've solved C, which basically means that we don't know our x, but we know our -9. So C just means when y equals -9, solve for x. That's basically all that's telling you. Okay, so we have, just like we had before, we started with our y equals 3x. And we know that y is equal to -9. So that's -9 equals 3x. Or you can switch it around as 3x equals -9. Exact same thing. So if we divide both sides by 3, anything divided by itself is just 1. So that gives us x. And you can put the x on the left and right, or right, doesn't matter at all. So -9 divided by 3, 9 divided by 3 is 3. Positive, well, negative divided by positive is negative, so x equals -3, or -3 equals x. So we know in this one, it's a -3. Okay, so that's how your completed table would look. All right, so let's do another example. So if you're still writing, feel free to press pause. Okay, so let's say, for example, we want to complete the table for the equation, say y equals 1/2 x minus 5, and our table, a little more pencil lead there, looks like this. Okay, let's say this is our x, and this is our y. And if we have, let's say, a -2 here, we have a 0 here, and if we have a 0 there. Okay, so we want to complete that table. All right, so just like in the previous example, we're going to go ahead and redraw our table. Okay, so if we have our x here and our y there. Okay, so we have a -2 here, a 0 there, and a 0 there. Okay, so just like before, we're going to make this one our A, this one our B, and this one our C. Okay, so we're going to go ahead and solve for our A. So we have a -2 under the x column. So we know that when x equals -2, we're going to solve for y, because we don't know what the y is. Okay, so y equals 1/2 x minus 5. That's what we're starting with. So 1/2 x minus 5. And we're going to replace our x with -2. So if y equals 1/2 times -2 minus 5. Okay, so 1/2 times -2, the 2's cancel out, so you're left with 1 times -1, which is -1. So y equals -1 minus 5. -1 minus 5 is -6, so y equals -6. Okay, so we know this spot right here is -6. Okay, so we know that when x equals -2, y equals -6. Let's find out when x is equal to 0, what we get. Okay, so for B, just drew a line to kind of separate the work so it doesn't get all mixed up there. Once again, we start with y equals 1/2 x minus 5. Okay, and we know here that x is equal to 0. When x equals 0, solve for y. Okay, so once again, we have y equals 1/2. We know that x is 0 times 0 minus 5. Okay, so anything times 0 is just 0. So we have y equals 0 minus 5. 0 minus 5 is -5. So y equals -5. Okay, so that means for this one, we're going to put our -5 right there. When x is equal to 0, y is equal to -5. Okay, so now we're going to go ahead and solve for C. Okay, so for this one, our x is the unknown, but we know our y is 0. So when y equals 0, this time we're going to solve for x. Okay, so once again, we're starting with our 1/2 x minus 5. But we know that y is equal to 0. So 0 equals 1/2 x minus 5. Okay, so now we have to go ahead and solve for our x. Okay, so just like before, if we're solving for our x, we have to get rid of every term that doesn't have an x. Okay, so we're going to go ahead and add 5 to both sides to get our x term by itself. Okay, so those two cancel out. So we have 1/2 times x equals 0 plus 5, which is 5. And I'm just going to switch those over for my own personal comfort. Move that up here. So 1/2 x equals 5. And again, if you want to put 5 equals 1/2 x, you're more than welcome to do that. So move that arrow over a little bit. Okay, so we have 1/2 times x. We have to multiply 1/2 times its reciprocal, which is 2, in order to get the x by itself. Okay, so if we multiply both sides by 2, these 2's cancel each other out, which is 1. So we have 1 times x, so we have x equals 5 times 2, which is 10. Okay, so we have our 10 right there. Let me clear that up a little bit so it doesn't look too awful. There we go. So we have our 10 right there. Okay, so whenever you see that missing spot in the table, all you have to do is plug in the one you know, solve for the one you don't know. All right, so really these tables will lead us right into graphing. Okay, now I'm going to show you how to use that to graph. All right, so let's go ahead and start on that. Okay, now just for that previous example, we know that y equals 1/2 x minus 5 has at least 3 solutions. Okay, we've already figured them out. Okay, so we have -2, -6. Okay, remember we figured all of them out right here. -2, -6, 0, -5, and 10, 0. We know those 3 solutions exist because we plugged them in ourselves. Okay, so we have -2, -6, 0, -5, and 10, 0. Okay, so we know of those 3 solutions. Okay, so actually we could find an infinite number of solutions that would be true for that. These are just 3 of them. Only 3 solutions. Out of an infinite number of ordered pairs. Okay, So you can come up with a bunch of different solutions for this. Okay. Now, once we find 2 or 3 solutions for a linear equation, all we have to do, plot those 3 and draw a line right through all of those points. That's your graph. Okay? So to graph an equation, you want to plot at least 2 points. But I always do 3 just for my own personal graphing needs. But if you want to do just 2 points and draw a line through those 2, you can do that. Okay, so we want to plot at least, clean that up a little bit. Two points and connect with a line through them. All right. So let's say, for example, again, looking at our previous example, this is just the example we just did. We're now going to graph that using the table that we just filled out. Okay, so what if we wanted to graph y equals 1/2 x minus 5? All right. Okay. So what if we wanted to use just 2 of our points? Okay. We have 3, but we just want to use 2. Okay. Like I said, 3 is just something you can do to be extra careful. Okay. So we have 2 points. Okay. We can use -2, -6, and 0, -5. Okay. Or if you wanted to, you can use -2, -6, and 10, 0, or you can use 0, -5, and 10, 0. It doesn't matter which 2 points you use. It's completely up to you. All right. So what we're going to do, I'm going to go ahead and draw the graph. And remember, most times you're going to use graphing paper or something like that. But we're going to just draw it out, where this is our x and this is our y. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Let me clean that up a little bit. And let me bring this down just a little bit more. Okay, so that's -1. We'll bring that down just a little bit. -2, -3, -4, -5, -6. And let's say -1, -2, -3, -4. Okay, so that's our XY axis. Okay, so first we're going to plot -2, -6. So here we have -2 for our x and -6 for our y. So we're going to go down -1, -2, -3, -4, -5, -6. Okay, so we plotted that point, and we have 0, -5. So if x is 0, it stays right here, and y is -5. So 1, 2, 3, 4, -5. All right, so we plotted our 2 points. So now we get any straight edge, and I'm just going to use an envelope that I have already opened. So we just draw a line right through those 2 points. Put an arrow on each end, and that is your graph. Y equals 1/2 x minus 5. That is literally it. You pick any 2 points. You could replace x with 1 and y with another value and solve for the other. You could pick any 2 points at all. And that would have solved right there. Okay. All right. So let me move this so we can do another example. All right. So let's say if we wanted to graph y equals x plus 1. Okay. So the first thing we need is we need points. We don't have any points. They just told us to graph it. Okay. So without points, we can't graph it because we need at least 2, and we have to draw a line through those 2 points to be our graph. Okay. So here, the first thing we're going to do is make a table. Okay, so we're going to go ahead and make a table where we have our x and we have our y. And really, like I said, you only need 2 points. You can make 3 if you want to. All right. So once you make your table, you pick any x value, any y value to start with. It doesn't matter at all. You just pick one and solve for the other. So if you want to make x equal 5 and then plug that in and solve for y, you can. If you want to make x equals 2, you can plug that in and solve for y, you can. If you want to make x equals -8, you can plug that in and solve for y, you can. If you want to make y equals 4, plug that in and solve for x, you can. It does not matter which numbers you start with. But me personally, I try to start with the number that will make my graph as easy as possible. Okay? So me personally, I'm going to make x equal -1 and x equal 0. Okay? Like I said, you can pick 2 other values to start with. It would not matter at all. These are the 2 I pick because when x equals -1, we have y equals x plus 1, which gives you y equals -1 plus 1. -1 plus 1 is 0. So that gives you y equals 0. Okay, so that gives you y equals 0. So you have 1 point there. You have -1, 0. And for your second point, you know that x equals 0. When x equals 0, you have y plus x plus, oh, y equals x plus 1. Sorry about that. But we know that x is equal to 0. So that means y equals 0 plus 1, or y equals 1. So we have -1, 0, and we have 0, 1. Okay. So that's why I picked those two. Those are really short points, and numbers doesn't get that big, so you don't have to graph really long lines. You can just go ahead and graph those two. All right, so since we have those 2 points, we're going to go ahead and make our graph. Okay, so we have our x-axis and our y-axis. So let's make that our 1, 2, -1, -2, 1, 2, -1. Make that a little bit lower. -2. Again, that's why I picked smaller numbers, because for this particular graph, I didn't want to have to make it, go all the way down. So if I would have picked 8 here for x, and that would have been 9, I would have had to make a bigger graph. So I picked smaller numbers to make a smaller graph. Okay, so we have -1, 0. So -1, 0. X equals -1, y equals 0. Right there. And we have 0, 1. X equals 0, y equals 1 is right there. Okay. So once again, you can pick any straight edge, a ruler, or like I'm using the side of an envelope, and just draw a line right through those points. Okay, and draw the arrows on the end. So that lets you know that that just keeps going on forever, and that arrow lets you know it keeps going in that way forever. So that's your graph of y equals x plus 1. All right, so hopefully that made sense. All right. Okay. So when you look at this graph, any point or any solution on that graph will all line up here. So if you pick any point on this graph, okay, the same way we picked -1, 0, we plug that in, it's true. We picked 0, 1, we plug that in, it's true. If we make our table, let's say if we wanted to make that with 50 rows, if you plug in an x value and solve for y, or plug in y and solve for x, all of those points will be on some point on this graph. Okay? Those will all be solutions. That's why you have an infinite number of solutions. If you want to make x equal -1, you get 0. X equals 0 is 1. X equals 1 would make y 2. X equals 2 would make y 3. And it will keep on going forever and ever and ever. Okay, those are all solutions. Okay, and all of those will appear on this graph. All right. Okay, so right now, we're going to look at the final thing we'll cover, which will be our x and y intercepts. Okay, so x and y intercepts. Okay, so x and y intercepts are pretty straightforward. Okay, the x-intercept is when the graph crosses the x-axis, and the y-intercept is when the graph crosses the y-axis. Okay, so x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. Crosses, let me clean that up a little bit. Crosses the y-axis. Okay, so now we look at how to solve for the x-intercept and y-intercept. And that's probably the easiest to remember. To solve for the x-intercept, you just make y equals 0. That's it. You make y equals 0, solve for x. To solve for the y-intercept, make x equals 0. That's it. Okay, so you have an x-intercept, you're going to make the y equals 0. To solve for the y-intercept, you make x equals 0. All right, so let's say, for example, we have for y equals 3x plus 17, find the x and y intercept. All right, let me move that up a little bit. All right, so to do that easily enough, okay, so for the x-intercept, we make y equals 0. Okay, so remember, we have y equals 3x plus 17. So if we make y equals 0, we have 0 equals 3x plus 17. Or 3x plus 17 equals 0. All I did was flip it around. If you want to write it as 0 equals 3x plus 17, you could. I just flipped it around. So now we solve for x. So if we subtract 17 from both sides, that gives us 3x equals negative 17. So now if we divide both sides by 3, we have x equals negative 17 over 3. Okay, so now we have that. We have our y is equal to 0, x is equal to negative 17 over 3. Okay, so that means our x-intercept is negative 17 over 3, 0. Okay, so that's your answer. Okay, now negative 17 over 3 is not your x-intercept, it's your x value. This particular point is your x-intercept. Okay, that's an important thing to remember. Your x-intercept is an actual ordered pair. Okay, so when y equals 0, x is negative 17 over 3. All right, so now we do the same thing for our x-intercept. Let me move that up a little bit more. Our y-intercept. So remember, for your y-intercept, you make x equals 0. Okay, so remember you had y equals 3x plus 17. So we make x equals 0. That's y equals 3 times 0 plus 17. 3 times 0 is 0. So 0 plus 17 is 17. So y equals 17. Okay, so that means your y-intercept is 0, 17. Okay, so that means if you graph y equals 3x plus 17, it will cross the x-axis at this point, and it will cross the y-axis at this point. All right, so hopefully this all made sense. Okay, and I will see you on the next video.